This is an overview of a 3D printer that I'm developing and sort of experimenting with this technology. The idea is that instead of depositing molten plastic out of an extruder as an FDM or FFM printer would, it deposits UV curable resin. This is the same resin that's used in LCD and DLP 3D printers. Now there are a few benefits to this. One is faster print speeds. One of the main limiting factors on 3D printers is that they can't melt the plastic fast enough because it takes a huge amount of energy to melt an extremely large amount of plastic. This would not need any heating element, or if it did, it would be very minor, and therefore that would allow for much faster print speeds because all you have to do is pump something that's already liquid. It would also allow for better bridging because instead of melting the plastic and then having it droop as it cools, you could have it cure effectively instantly as soon as it's hit by a very powerful UV light or possibly UV laser. That would allow for finer detail control, less drooping. You wouldn't need a part cooling fan. Basically, it'd be an almost infinitely effective part cooling fan. Another good benefit would be infinite colors and materials, because normally you'd have to combine a large amount of filament. This could just have a bunch of tubes with different materials, different colors, whatever you want, being fed in and then all combining right at the tip of that nozzle to form the mix of materials, a transition between materials or colors or anything like that. And because it's not an FFM or FDM printer that relies on melting plastic, you can print materials that would normally have extremely different temperatures. For example, printing from PLA to polycarbonate and a multi-material nozzle would be extremely difficult, if not impossible, because the temperature difference is huge that you need. With this, there is no temperature difference, it's all the same. So the first thing I tried for this, which I determined was not viable, was a peristaltic pump. So if we look over this here, there's a stepper motor that spins this inner part, and that has rollers that would squeeze a tube around here, pumping out resin. I went through many revisions of this with a lot of different parts. I attempted to use these small herringbone gears with a gearbox in order to have higher accuracy out of the pump, and torque was also an issue at first. The motor was a bit limited on that front. But at this point, I've determined that that's not the most viable solution, because every time this roller passes over that area, and there's kind of a dead zone in there, and that dead zone results in a very pulsated flow. I did not expect that to be the case at first, but it makes a lot of sense, and I don't have a great solution for it. My best solution that I could come up with would be to put an encoder on this outside, track the position, and kind of tune it so that it moves more quickly in this area and less quickly in this area in order to compensate for the pulsations. But that would still be extremely difficult to get to be accurate. So I've determined that that's probably not the best option. That is why I have developed this. So this is a resin extruder pump with a fairly simple construction. There's a stepper motor down here that goes to a shaft coupler to this M8 Acme rod, and that works with this anti-backlash nut to push this carriage forward and backwards, which, as you would expect, can push into this 100cc syringe and cause the resin to flow out the end. So this has just some drylin bearings inside, and so whenever you push that, it just simply moves in and out. At this point, it has not been tested for printing out of a nozzle because I need to machine a new nozzle. For my original test, this monstrosity was used. It has these UV curing LEDs here. It's a 3D printed nozzle. These four sides are plugged. I originally made them hoping it wouldn't leak, thinking I could use different colors. And then it has this thin silicone tube that is used with the peristaltic pump. And it also has a button, because this was effectively a 3D printing pen, which I determined was the most efficient way to really test that the design worked before I really struggled with it being on a 3D printer. So I printed a couple of these nozzles, trying to just adjust the hole size until I got a small hole at the end. and that wasn't great. I did end up making this piece, which is an aluminum piece with 1/8" NPT holes around the outside that go to small center holes, and then it has this port here, and I made a nozzle for that. This is the nozzle piece. You can see there's a very small hole in there that is roughly 0.4 mils, and then there's that larger hole there. I made this for M3, couldn't end up getting an M3 die, was able to modify this, but haven't made this yet. This is now M5. So that's the basic progress right now when it comes to designing and machining. The next steps are to wire and test this with a stepper driver, and that will be done shortly. There's also, I have to make the nozzle and the LED array, and then I have to test it. Probably going to use the same LED array and possibly replace that with a laser. Then of course the next step, and that will be for a 3D printing pen. The next step after that, if that works, put that in a printer. If I can get that working, multiple colors. So that's kind of how this project will progress, and the videos will progress in the future. Thanks for watching. Please like for the YouTube algorithm, comment any feedback or suggestions, subscribe if you want to see more videos on this or new projects that I have coming in the future,